Hi guys, welcome back. This is Mansa from Sri Venkateshwara College of Engineering, Bangalore, third semester. So today in this video, let's see a topic which is related to digital design and computer organization. So the topic is streamline the Boolean equation based simulation system using K-mapping. We can use the sum of products method to generate any digital logic circuit for which we can write the truth table. While the sum of products method will always produce a correct circuit, it usually does not produce the optimal circuit using only the minimum terms of a function. We want the simplest possible circuit because fewer gates or simple gates mean reduced cost, improved reliability, and often increased speed. So we can simplify a circuit by simplifying the Boolean expression for it. Then using the techniques already learned to produce the circuit that is equivalent to the simplified expression. The need to simplify Boolean expressions occur in programming as well as hardware design, and technologies discussed here are equal to the programming. Now let's see how to simplify the Boolean expression using the laws of Boolean algebra. One way to simplify a Boolean expression is to apply the laws of Boolean algebra, some of which are summarized here. For example, we can simplify AB plus AB bar as follows. The original expression given is AB plus AB bar. On taking A as common, by applying the distributive law, we get A of B plus B bar. Again, on applying the inverse law, it is A1, that is 1 into A by commutative law. According to the identity law, 1 into A becomes A. Therefore, AB plus AB bar expression is simplified to A using Boolean algebra. So here let's see about K-maps. K-maps are graphical way of using the relationship AB plus AB bar is equals to A to simplify a Boolean expression and thus simplify the resulting circuit. A K-map is a completely mechanical method of performing this simplification and so as an advantage over manipulation of expressions using Boolean algebra. K-maps are effective for expressions of up to about 6 variables. The K-map uses a rectangle divided into rows and columns in such a way that any product item in the expression to be simplified can be represented as the intersection of a row and a column. The rows and columns are labeled with each term in the expression and its complement. The labels must be arranged so that each horizontal or vertical move changes the state of one and only one variable. So in this slide, let's see how to use a K-map to simplify an expression. First step, draw a map with one box for each possible product item in the expression. The boxes must be arranged so that for one box movement, either horizontal or vertical changes one and only one variable. For each product term in the expression to be simplified, place a check mark in the box whose labels are the product's variable and their complements. Third step is draw loops around adjacent pair of check marks. Blocks are adjacent horizontally and vertically only, not diagonally. A block may be in more than one loop, and a single loop may span multiple rows, multiple columns, or both, so long as the number of check marks enclosed is a power of 2. Fourth step is, for each loop, write an unduplicated list of terms which appear, that is, no matter how many times A appears, write on only one A. Fifth step, if a term and its complement both appear in the list, for example, both A and A bar, delete from the list. Sixth step, for each list, write the Boolean product of the remaining terms. The seventh step, write the Boolean sum of products from step 5, that is the simplified Boolean expression. So in this slide, let's see K-maps for expressions of two variables. So let's start with the expression AB plus AB bar. So this is an expression of two variables. We draw a rectangular and divide it so that there is a row or column for each variable and its complement. Next, we place checks in the boxes that represents each of the product terms of the expression. The first product term is AB. Since the expression is AB plus AB bar, the first term, that is AB. So we place a check in the upper left block of the diagram. The conjunction of A and B. The second is A, B bar. So we place a check in the lower left block. Finally, we draw a loop around adjacent pair of checks. The loop contains A, B, A and B bar. So we remove A so that the list is unduplicated. The B and B bar cancel, leaving only A, which is the expected result, that is AB plus AB bar is equal to A. So now let us try a slightly more interesting example. Let's simplify A B bar plus A bar B plus A bar B bar. So there are two variables. So the rectangle is same as the first example. So we perform the following steps, that is place a check in the A B bar area, place a check in the A bar B area, place a check in the A bar and B bar area. So now draw loops around the pair of adjacent checks. The K-map appears as shown in this figure 2. Because there are two loops, there will be two terms in the simplified expression. The vertical loop contains A bar, B, A bar and B bar. So we remove one A bar to make it unduplicated list. The B and B bar cancel, leaving the remaining, that is A bar. From the horizontal loop, we remove the duplicate, that is B bar, then remove A and A bar, leaving only B bar in the second term. So we write the boolean sum of these and the result is A bar plus B bar. Thus, the simplified form of this expression, that is A B bar plus A bar B plus A bar B bar, is A bar plus B bar. So now let's see the conclusion of this topic. There are several possible forms of K-map, including some three-dimensional versions. All that is required is that a moment of one position changes the value of one and only one variable. So we have shown a form for maps of 2 and 3 variables. So below are the maps for 4 and 5 variables. Thank you for watching this video and please give a like.